Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
There are a couple calculus theorems that might seem pretty logical, but we still have to state them anyway. So the first one we're going to talk about is Rolle's theorem. Okay? So if f of x is smooth and continuous, on AB, which means differentiable, right? And f of A equals f of B. Then there exists some C in AB such that the derivative is equal to 0. Okay, so first of all, you have to check, is it smooth, is it continuous? And you're just checking a window, right? But the big thing is who cares about your x and your y, really? But we'll go ahead and get it on here. So picture some smooth, continuous line. Here is A, here is B. So between A and B, it's smooth and continuous. But f of A and f of B are equal. Well, if it's smooth and continuous, then it could be doing anything in between A and B, but it has to be connecting somehow, right? Even if it's doing that. In this case, I've drawn it such that there are two C's. It could have just been one, right? In fact, generally, you would look at a window so that it is just one. Make sure they equal. It could have just been this. But again, the derivative of the tangent line would hit 0 at some point in time. That's all Rolle's theorem is saying. Okay? So smooth, continuous, f of A and f of B happen to be the same thing. Okay? So let's try. Let's see if we can apply Rolle's theorem first. F of x equals x cubed minus 9x. So we know x cubed minus 9x is a smooth continuous polynomial. And we have the interval -3 to 0. Well, 27, right? -3 cubed is -27. Plus 27 is 0. So -3 is 0. And when I put in 0, I get out 0. So yes, f of A and f of B equal. Okay, so Rolle's theorem will apply. So we'll derive set it equal to 0. So x squared would be 3, so x would equal plus or minus the square root of 3, but we're on an interval between -3 and 0, so the c value would be at -square root of 3. That is where the derivative would happen to have a local minimum from a previous video that I did. Okay? Or a local maximum, right? Okay, so the mean value theorem. That one's a little bit tougher and not quite as common sensey, but once we talk about it, it will make sense. Okay. So again, continuous smooth interval. So on A to B, right? There exists some C such that the derivative at C is equal okay. So let's think about that. This is the slope of the tangent line. This is the slope of the secant line, or instantaneous velocity and average velocities. Okay, so you have, say, an average velocity of 50 miles per hour. That means there must have been some instance that you were going 50 miles per hour. I mean, some you probably went faster, some you probably went slower, but at some instant you were going 50. That's all this is saying. It's comparing the average velocity to the instantaneous velocity. Okay, so the other thing is let's turn this into y2 or y minus y1. That's how I'm going to write it. Slope of the tangent line equals y minus y1 over x minus x1. I'll just call it that. It's the same idea, right? If we were to multiply this over, slope of the tangent line, x minus x1 equals y minus y1. Isn't that point slope form? Absolutely is. We've kind of been using the mean value theorem as we did point slope form to find equations of a line. But visually what that looks like is if you have some kind of interval, A to B, it has a secant line. And at some point in time as you're coming along, your tangent line has the same slope as your secant line. That wasn't very parallel. Okay, that's all it's saying, is that the two slopes are equal. In other words, the lines are parallel. Your secant line is parallel to your tangent line. That's what the mean value theorem is all about. When is my instantaneous velocity equal to my average velocity? And it has to be on the window. So let's give that a try and see if we can't find it out. F of x is going to equal 5 minus 4 over x on the interval from 1 to 4. Now, I know this is undefined at 0, but in our interval, it is smooth and continuous, so we can go ahead and do the mean value theorem. Okay? So I'm going to rewrite this so that it's easier to derive. I'm going to rewrite it as 5 minus 4x to the negative 1. So when we derive that, we get 4x to the negative second, or 4 over x squared. Okay, now the secant slope. So the slope of the tangent line, that's at 4 over x squared, right? Let's get that slope of the secant line. Okay, first of all, I need ordered pairs. If I substitute in 1, 5 minus 4 is 1. If I substitute in 4, 5 minus 1 is 4. Looks like the slope of the secant line is just 1, because 4 minus 1 over 4 minus 1 is 3 over 3, which is 1. Okay, now we can solve this. So we'll get 4 equals x squared. So plus or minus 2 equals x, but only 2 is in our interval. So that's our answer. That's our c value. So they'll say c equals 2. Because it said for some c and didn't say for some x. So technically we should be plugging in c. Okay, so that's a look at the mean value theorem and Rolle's theorem. So again, Rolle's theorem says, hey, look, smooth and continuous, and these are at the same height. You're going to have a max min in that window. Mean value theorem says, hey, at some point in time, your instantaneous velocity is going to match your average velocity. So make sure you check your vocab words to see what they're talking about, and good luck with it.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Then drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.